Yeah, please.
Okay. May I share my screen? I just want to show my results.
Okay, please. Yeah.
Okay. This is my result on my calculations. I
Uh-huh.
got the ratio to be 0.2463 and so on.
Uh-huh.
Okay, then I found the logarithm by using t. There is a function of t, so I used it,
Right.
which is my own temperature times epsilon divided by Boltzmann constant, right? Boltzmann constants go with Boltzmann constant, and I continue the calculations. I ended up with having 0.0045, right?
I don't think that's the one. Let's go back to a little bit, go up a little bit. So
Okay.
point, yeah, no. The first one you'll see the delta G. You have the delta G is for -2, then yeah. So you have
This is my own temperature.
116, yeah.
This
Point,
is my epsilon.
yeah. Mhm.
Okay. Is everything good?
Looks good. And the temperature, we think we have the units of K, right? So
Uh,
this already been K, not epsilon. If you please double check that. Yeah. Okay.
uh,
Looks good.
I
Yeah.
didn't get it.
Yeah. Looks good. Looks good. I think that
Okay.
one, your that's a good results. Yeah.
Okay. So when I went to the tutorial, I
Mm-hmm.
looked the number that he got. Okay,
Yes.
0.01287
Yeah.
times
But
7
here we use
times
the
epsilon.
epsilon. Yeah, we use the epsilon as the units of K. So it's okay. Yeah. Yeah.
Uh, okay, so I tried to find this number and I couldn't because when I went to Ubuntu and I tried to get the result for the
Mm-hmm.
tutorial for the solution, I got 0.05529 and so on. Okay, I tried to use that as a and calculate it, and I didn't get the same. I got uh, where is it? I got it to be 0.00582, not 0.00128.
Okay. I've
I
not.
don't know how did he do
Now you
it.
use the same n, right? So n is 216. The same n. Yeah. Then
Yes, I used the same n.
yeah. Okay. I
Yes.
did not get you. So once you follow, uh, you already, if you use 0.55, so what you can get? So
What I didn't get the numbers that this number. So delta G over N equals to this number. But when I used the number in the tutorial or the solution, so I went to tutorial and solution, the production solution, the example output, I didn't get a ratio that could give me the number that he wants.
okay, if I understand clearly, you say you cannot repeat what is right in the
Yes.
tutorial, right? Yeah, I think it's
Yes.
very common because they make different version of the tutorial, right? So what we have it may be different from what he is writing. Yeah, it's quite normal because people keep updating their programs. Yeah, it's fine. Yeah, just know how to do that, and your number will be a little bit different. You just need to know what's the procedure exactly. So it should be fine. From my side, I saw your results. You have used the T as a 0.2, right? So it looks good. Yeah. I mean your T or pressure. I think your can I see your parameter you get assigned?
I got a bit of an issue. I
Okay,
cannot
should be
read
fine.
right
Should
now.
be fine. Yeah, I think it is in that order. Should be fine. Yeah. Yeah. For the rest, if you want to have a little bit 5 minutes, it's okay for the pray. It's fine. Yeah.
So doing like this is not an issue, even though that his result is not the result that he got. So because I don't know how did he got his results.
Okay. Because I can understand that the number may be exactly the same, right? They may change a little bit. If you do the tutorial, you will see sometimes even the input file in the folder, it will not consistent completely. You guys may already notice that, right? So you need to make your own judgment because people write the tutorial, they are not check everything yet. Yeah, they have some inconsistency. As I said last time, there's a trick. You need to use what is comes in the output. If you use that one that not been tested, I mean in the upside folder, it's a little bit different. I think you all already find that if you already go far, come to this stage, you already notice that.
Other thing, Victor, is I tried to get other people's calculations or numbers and
Uh,
ratios, and there is something that I didn't get very much. I'm not sure that it's right or not, which is that each time or as temperature and pressure increases, the ratio increase, right?
there's a variation. So that will be a domain of there's a range. There's a range for
Yes,
yeah. Each time they will get the difference. Yes.
yes, but and the ratio also increases. This is what I found
Yes.
from the others.
Yes. Yeah.
But
In general,
as
it will increase. Yeah.
yes, but as the ratio increases, the logarithm importance gets reduced. Okay,
Hmm.
so it might at some point get to the negative, which is strong because of uh, having it in the negative side is where the HCP is stable. So I don't know is the equation is really checked by all the ratios, or it might be wrong at some points.
Yeah. It's not true. All right. If we fix the sigma and the epsilon, what you said is true. But right now, the epsilon and sigma is changing. So the temperature and pressure is another domain that we are not keep. So what I said, right? If each of you, I just want to try to avoid you guys do a little bit copying from each other, but you guys learn how to do this procedure. This is the most important. If we keep the force field as the same, but we increase the temperature and the pressure, then eventually they will have a cross point, right? So one is more stable than other. Yeah, there's a phase change.
Yes, one of them is, would be more stable than the other, but
Yeah.
increasing the temperature and pressures mean that FCC will get more stable or will get faster to stable. But the equation may at some point get the opposite of that, which will show, for example, that that HCP is now the stable, even though that we are increasing temperature and pressure. Because from what I
Yes.
got,
Yes. What
is
you said is correct. All right. In general, if you know a little bit, in general, there's a trend. The BCC is stable at a lower temperature and pressure. Then if you go higher temperature and pressure, you go to HCP. Then you go to even go even higher temperature and pressure, you will go become FCC. That's some general trend for such a change.
Yes.
You're
So
right.
the top phase is FCC, but the equation may at some point. I don't know. I didn't check. I don't have a whole range of ratios and temperatures, but
Yeah.
I got a bit suspected about the ratio because of how much it increases.
Yeah. If we have enough computing resources, then we can do a large range, more points. Then we can find the phase diagram, which one is more stable than, at which, for which. Yeah, that's the practice. This project asks you guys to how to judge, right, the system in which phase, right? Eventually, later you do a larger project, then you just need to do more points. Like our project 2, we do 40 or 50 points. Then we have, we have a isotherm, then steel plot, etc. So you need to do more points. Then you get a domain, have a diagram. Yeah, what you observed and your feeling is right. If we increase the temperature and the pressure, then it will eventually change.
Doctor, will it change even though that the writing is that it's FCC, but it shows that it's HCP?
No, it will not change by itself because the self is limited by the boundaries, right? It will not change. If we understand like this, is maybe easier. Say, although it may, although it may have higher, higher energy. So in general, the lower energy is more stable, right? But now you have the limitation. It cannot freely go from this side to another. So it's called, you can think it like a overheated, or, how say that, we do the ideal gas, right? We have the diagram, it's called for the liquid to the solid sometimes. So it's, although it's passed through the melting points, but it did not crystallized, right? So it's called super cooled, right? Overcooled liquid. It should be crystal, but because there's no condition to form the core of crystal, so it will still be liquid. Yeah, that's something. Although you have lower energy, but because there's no transition conditions, the volume will not freely to change, etc. Then it will stay in the same phase. For example, it will stay in the HCP. It will not do that automatically because the limitation of our model. Right? Our model already fixed it because we use the periodic boundary condition. So it will not change the phase by itself. That's why we need the two configurations, right? Configuration 1 and configuration 2. We only compare there's free energy to check which one is more stable. But if we do experiments, then it may change from one to other automatically. But do simulation, you have no such conditions. May I answer?
Thank you, Doctor.
Yeah.
Yes, a it.
Yeah. Okay. Yeah, through this project, I hope you guys get the feeling, right? How to deal with the phases, different phases, how to calculate the Gibbs free energy. Instead of directly calculate, we calculated their probabilities, right? Then you're you solve this issue. Yeah, I think the phase change is play a central role of all the materials behaviors. So once your phase changes, you totally, story changes. Think about, you may know, life or death. You can think of like two phases, right? Phase one, you're living, you're a good one. Then second phase, totally different behavior. It's easy to understand like this. I feel that you guys have much less difficulties in project 3. I know. I want to know from your side, what's the feeling? Is because we only calculate 1 point, or is a tutorial is a better understanding, or is anything, or you already have no difficulties to run the simulation, to run the Monte? Is anything you can tell me how I can do better later?
Yeah, Doctor, I have a point.
Yeah, please.
At the beginning in Project 1 and Project 2, we found ourselves spending a lot of time trying to do the simulation. But I believe that our main focus should have been in understanding and analyzing the simulations. So for later semesters, maybe you can tell them the steps exactly how to make the graphs and make more points on analyzing the data. I think
Okay.
the focus should be more on analyzing.
Yeah,
because at the end we will be able to simulate after 3 projects. We will learn it automatically.
Yeah.
I agree with my colleague Yasin Hawaj. He is right, Doctor. I think this is what I was going to tell you about.
Okay, good. So it's clear that eventually you guys know how to do it, get the skill, right? You know how to do it, but even then later we can do later, maybe in our main task later for the project, larger project, right? For the masters, you will have larger projects in next semester. So in that, we will learn more how to do the analysis, how to get the physical meaning from this data, right? From these digits. I think it's a very good question. But as you guys know, if you need to know the basic sense, the skills, how to write Pythons, how to run the comments, Ubuntu, etc. So yeah, it's a good question. Yeah. And I will take that in mind. I will hope later we can do more analysis, discover the meanings. Yeah, thanks for these insightful comments.
Doctor, for this method of defining the phase, how can we use it for like the artificial phases, for example, the not natural like carbon nanotubes and such?
Exactly. You can do that. All right. The only thing you need to do, you need to change or switch. Now, right now we have HCP and BCC, right? You can change to whatever you want to compare. You will see. Now we compare HCP and BCC. If you want to compare HCP with B2 phase, there are many phases. I say that the crystal, they have 230 different crystal structures. So you may have many different phases. You can see this one is good for compare 2, right? I know 1 and then another I compare. Yeah, but the difficulty is sometimes you do not know which phase it could be. So you will be guess. Yeah, you say maybe in phase 1 is BCC, phase 2 maybe FCC. You can compare FCC. Use the same way, all right? Use the same way, same method. Yeah.
Even if they are not like naturally occurring, so like nanotubes and such, it's okay, it's normal, even if they don't occur naturally.
Yeah, but you know, if you don't compare these two, you'll get a clear answer. All right, I can compare these two. Yeah, the difficulty is sometimes you don't know what exactly you should compare to. Right?
Yeah, I can see, yes.
Yeah. How about how you guys do the analysis? You still use Python to do the plotting, or use NuPlot, or use Excel, or use Origin? What's the main tools you do the plotting, your analysis?
Mostly I use Python still.
That's good. That's good. Because personally I like Python. Is free and you have your control. Once you know how to do that, you can do such things in batch. Eventually you will see, I want to plot for thousands figures. And you can do it in just a few seconds. If you say, okay, I like Excel, then you need to open the file one by one. You take a lot. It's good to do 1 or 2 plots, right? It's fine, almost the same, right? Even Excel maybe faster. But if you do more calculations, then you'll find it's very convenient to use Python. Yeah, that's why I highly encourage of you to do the analysis, use Python. All of you learn Python well. Yeah.
Speaking of the plots, we will use all the plots for this project. So what do we include in the appendix? Because there is nothing extra. There is nothing like the inequilibrated or anything like that. All the plots will be included in the results. So what do we put in the appendix?
In the appendix for this one, if you have your Python code for the plotting, you're welcome to include the appendix. As I said, the appendix is not for me, just for yourself. Think about maybe 5 years later, you look at your reports, right? So you may forgot, you cannot find, you already changed a few computers. It's hard to find it somewhere, right? It takes time. So you put it in one place. Eventually you can find it later for your own convenience, right?
I see. Thank you.
Yeah. It's not for me. I will not grade your appendix. I just tell you what's a good custom to do things. Put everything together. I heard the joke, or it's about the soldier. The soldier, it's called, I remember it called 23rd rule, the army rule. Right? If the weapon have 2 parts, in general you can't find another, right? because if you try to use it, it's always in urgent situation. But if it's in urgent, and for example, you have the gun, in general, you'll be very hard to find your bullets if you do not put it together. Because every time you're trying to find it, you are in urgent. So you have no time to find the others. So always put relative parts together. You may also have your personal styles like this, and share a little bit about that. So we have our shoes, right? We also have something like a stock. something, then do not put that far away. Always put, together. Then you can easily find it. Sometimes if you put far away, you never find it together. Yeah, that's something. Right. I also noticed that you guys request the switch of the final exam. Is final already correct that in the registrar's website?
Yes, Doctor.
Okay, that will be perfect. All right. So I do. Yeah, each of you please announce it in the Telegram, so no one will be left.
Yeah, but it is for only the master. Yeah, our colleagues from the administration. Yeah.
Okay. Yeah. Okay.
Don't worry. So for master.
Yeah.
Okay.
I really appreciate your efforts. You guys have such efforts. Yeah. If I can do something good for you, please let me know. Yeah. Convenience. Yeah. Beyond that, I think I also working with I think one of the students, and let me see is here or not. Massa is not here today. Yeah. We're still working with Oracle, all right? We're trying to find some good projects so you guys can take a part in next semester. So eventually, in the next, I think the first 2 weeks, you need to set down your project title. There is, please start looking on what do you guys like to do.
Doctor, I have interest about desalination systems, especially the membrane. And you have mentioned that in last help session you told us. So I'm just informing you about my interest in that. And I can find some people who can help. So I have to work from now or? Yeah,
from now, I hope all of you, please find your best, your goal company and contact with the manager there. Say I'm graduating from FPM in the summer, right? I'm doing this interesting project. If you are also interested, I'd like to, to use our method to solve your question in practice. Then in this way, you will make the manager know you, right? Then you have the much better chance than if from middle of nowhere. Yeah, just give you the chance. Yeah, please.
Yeah. And it is like I go for him, I tell him that I can make a case study for you, for your membrane system. Right.
Then the manager will also, first they already know you're good from a good university, you're doing your interest, and you're energetic, right? Then it reflects you have the ability for communications, right? You can convince others.
Yes.
So it will make you outstanding from many other candidates. So please try your best to connect with the ideal company. All right.
Yes. And it's only one project, Doctor. I cannot go for two.
No, only one. Yeah, because there's
only one.
No energy. You have no time for another one. Yeah, please do one. Good. Then you demo your ability. The manager will appreciate, and then you will be, eventually you will get your job. I don't encourage you guys to do such like a research topic. As I said, the company pay double or triple than universities, right? So you will have better life and do the same thing, almost the same thing. Yeah, same job, but get well paid. Yeah.
Doctor, do you think, like with the knowledge we will gain next semester, we will be able to use computational simulation for things like catalysis and such?
Yes, I will provide the computing resources. All right. So each time you will go to the company, you're sure. All right, we have computing resources, so we can do this job for you, etc.
Yeah, I mean for the knowledge more so like how much what will cover the scope. Will it be enough for example, for simulations about catalysis, for example, topics like that?
For catalysis, if you're doing molecular dynamic simulations that will not take, or Monte Carlo simulations that will not take much, right? For example, you already have the feeling about project 1, 2, 3, right? For the heaviest duty for project 3, how many, for 1 point you use, if we take say 10 hours, right? Then say if you have 1 project, you do how many? Say you have such 50 points to calculate. So that will be about 50. You will not do that heavy duty calculations, right? If you need heavy duty calculations, you will use your, say, okay, my design may be wrong. I will trying to reduce. I will find a better method to do, right? You will need think a little bit, find the right tools. That's important.
Victor, I think thinking from now about the project in the next semester will be hard because we have exams now. I think it's better to start it in the beginning of the next semester.
Yeah, you guys should start looking at the good company you'd like to go. Then you find your project, right?
In the next semester, yes.
Yeah, think about it more or less like your make a girlfriends. You find a girlfriends first, then you find the topic to chat each other. That's more or less the second.
Okay, thank you.
Yeah, you find your target, your ideal, girlfriends first. Right? That's something.
Wife, not girlfriend.
Okay, wife, yes. Then you find the project is something you can talk about. Then that's another way. Just a channel. So something you have something to talk.
Good, thank you.
Yeah. Yeah, I think no worry. Some of you worry about your scores from the project 2, project 1, 2, and 3. As I said, I will try my best to balance a little bit. Right, I try my best to give most of you full scores. Right, this is my promise. Then please try your best to do the good in other exams. Right, do the other exams. So you will eventually you have you're looking for a job. People say, okay, I do good at this practice, etc. I hope I can give you a plus. Right.
Thank you very much, Doctor.
Yeah. If any other questions so far?
Oh, Doctor, we should submit the project through your computer, right? Not Blackboard, right? The third project.
What do you say? The project 3, you say?
Yeah, should we submit it through Blackboard or your computer?
No, Blackboard. Put everything on Blackboard. Yeah.
Okay.
Yeah.
Doctor, for me about project 3, I have went through the tutorial, but I'm kind of not understanding the main thing that is happening inside the simulation. Okay.
Which part? Yeah. Which step you're in, for example?
I read it maybe all of it, but I have difficulties in understanding what is happening. If you can just briefly introduce us again to it, so we can.
Okay.
What's happening?
All right. So for the project 3, as I said, we're trying to determine
Yes.
which phase is stable than other. Right now, we compare HCP and BCC, right?
Yes.
What do you need to do? First, you say, what's the characteristic of BCC? What characteristic of HCP? Then this characteristic is is the order parameter. We find what's the order parameter for FCC and
the lattice structure.
Yeah, as a structure. So structure is different,
Yes.
of course, but the computer need to understand. They will give it the scores, right? If you go give scores. So eventually computer will find a way, right, to say one phase, right, it have order parameter is negative, the other is positive, right?
Yes.
Yeah. So okay, you will clearly tell, right? It's positive, then one phase is negative, and yeah. All right. So the step one is just simple like that, right?
Yes.
Then if we go positive, negative, that will be infinite. But the computer do not like infinite because the computer like a discrete line, right? So in this way, the computer say it will be very inefficient to do from 0 to 1 billion, right? It will be more you're the better keeping a range, a short range, for example, 1 to 10. Then okay, he can do the job for 1 or 10. Do not give the infinite, right? So step 2, computer do the BIOS, the sampling.
Doctor, okay, if we have the order parameter from 20 to 20, what does that mean? I know it is if it's -1, it is FCC, for example, and if it's 1, it is HCB. What does it mean if it was 20?
For example, if we have the number 20 in step 1, that means okay, instead in general we say is positive. That means from 0 to infinity, right? Now, instead of infinity, large range, now we only have clearly is from 1 to 20. Then we can limit our, you will tell the computer, do not do the meaningless testing beyond 20. Please only to 0 to 20. Then the computer, then each time you're trying, because Monte Carlo, right? You make the random number, then computer will generate the random number scale to 0 to 20. Then you will see each time you make the random number is valid, right? It's not we are not be if is far away from 20, above 20, then it's that's just nonsense, right? So, but
exactly, yes. Maybe I get it. Yes.
Yeah, that's more efficient, right? To do the
That's very cool. Thank you, Doctor. Thank you.
Yeah. I think you guys play the game to show the dot, right? If you have your circle on the wall and throw the dot, right? This way, for the BIOS one, to make every dot you've been there around the range, right? Yeah, I think you know what that means.
Yes.
Yeah.
Doctor.
Yeah.
About the last step, the production. I have found the ratio of the pressure ratio B1 over B2, and it comes like 0.08. It's positive, and I have substituted in the formula that is in the slides. It becomes a positive number. So
negative, right?
I don't think so.
Wait 1 second. So is point, for example, you said your number is 0.08. So let's say it's 0.01. All right. So 0.01, then you take the log.
So, 0.08. It is.
Yeah. So you put the log. Yeah, log. That means how? Can you show your screen to see that?
Well, I didn't write. I just do it by the calculator. I didn't write it in my laptop or in
okay, it's fine.
file.
It's fine. We can estimate, right? So you have the formula minus t, k minus kt and the log, right? So log, then you have the log because it's smaller than 1. So you have lactive, then you have yeah, you have positive. It's positive, yes.
Yeah, but the problem, doctor, I didn't use K. I
think
found
you're fine because your range, yeah, 0.08 is reasonable. It's good one.
0.08.
0.08, yeah, 8, yes, yes, it's fine.
0.08. Okay, and that's
yeah. So it's around 0.01, right?
Should we use the formula delta G, the Gibbs free energy, minus KBT log B over B2? Because this is what
you should use that formula. You should use that formula to calculate the difference in Gibbs free energy. Yes.
Okay.
Then you can judge. Yeah, and please. Yeah, I think you're almost there. You're in good results. Yeah. Yeah, if you get something well beyond that one, maybe have an issue. Yeah, it looks reasonable. Yeah.
But Doctor, what does this value represent? The delta G. I know we can't judge if it is positive, it is FCC, and if it's minus, it's SCB. But what does it mean?
That means
rather than what it represents.
That's relative stability, right? It Gibbs free energy determine the stabilities, right? So if one larger than other, the lower the better. Right? You will find which one have a lower Gibbs free energy.
The lower the Gibbs energy, the better result or the better structure.
Yeah, better stability. Yeah.
Okay.
Yeah.
And my number is 2.9 multiplied by 10 to the minus 24, the exact number for delta Gibbs energy.
Yeah, I think right now we calculate the relative. Yeah, it should that small. You said 10 to the minus how many?
It is 10. It is 1 to 1.38 multiplied by 10 to the minus 23.
I do not have the figure of the number. Looks okay. Looks okay. Yeah.
You can write it.
Yeah. Please write, because sometimes I need take me a little bit. Yeah, I do not have the sense. Yeah. Let's see your chatting zone. If you can type there. Yeah. Well, it's so okay. No.
This is the Boltzmann energy.
That's Boltzmann. Yeah, I think this one is very small. Yeah, it's KB. We use that as a units actually, right?
Which unit?
We use the units of a K, right? We already have K. Yeah. Please figure out the unit there. I will go tell you the details, but please figure out. Yeah.
So I should change the unit.
Yeah. Please change it.
Otherwise,
it's clearly 0. It
okay.
can be minus 23. Yeah.
Okay, that's why I.
Yeah. Doesn't make sense. Yeah, the computer the machine per second is only minus 16, right? So if it's the digits over than minus 16, it's clearly 0.
Okay.
Yeah. By the way, how you guys feel the number? So 10 to the minus 5. What does that mean? 10 to the minus 5. 10 to the minus 5 means 1 hair from your head, right? Your head, how many hairs for each of you? You have around 100,000. So 10 to the 5th. So 10 to the minus 5th is really a small number. Keep that in mind. Yeah.
Doctor,
Yeah.
Can I share my screen?
Yeah, please. Yeah.
It is not. The host is disabled.
Yeah, please share your screen. Yeah.
I can't. You disable the screen sharing.
Oh, okay. Let me allow you. All right, wait 1 second. Yeah. Sorry for this. Yeah, please.
I have used this equation.
Yes.
Okay.
Yeah, use that equation. Yeah.
Yeah, no problem. But what I didn't understand is, what do you mean by this slide? Okay, I use this script.
Yes.
I have found P over P.
Yes.
But I didn't understand the rest of the slide. Also, this slide, I couldn't figure out what do you mean by it.
Yeah, I think just now one of our classmates have go through this. Could you please share yours?
What?
Wait a second. I forgot the name of the classmates. Yeah, this someone can help him. All right. If not, I let's go through. All right. So here you already know P1 over P2, right?
Yeah. Yes.
Yeah. Then you already know the formula, right? You know the formula. You just showed, right? The formula is delta G equals minus KT times log P1 P2, right?
Yes.
Have the P1 over P2. Then you can calculate the delta G, right?
Yeah, and I have the temperature, and I have
yeah. You have the temperature at this. You just plug in, then you can calculate the delta G. Then, right, so you already have the delta G, right? In this case, divide the value delta G by the n, right? You know the n. N is 216, right? In the configure.
It's in the control file and the feed file.
Yes, exactly. So you will get this eventually. You go through this, right?
Yeah. So then so the temperature, I should substitute this temperature here.
Yeah,
the epsilon. Yeah. What does epsilon here mean?
This epsilon is Nina-Jones potential. I assigned the value for you. Yeah.
So what you have given us. So the Boltzmann constant here will go with the Boltzmann constant.
Yeah, it's constant. It's Boltzmann constant. Is you will see here is a unit.
Will cancel.
Right? Yeah, it canceled. Yes, exactly. The previously you do not need to care about that. It's you canceled.
Because I have substituted the 0.2 since
you just put actually what you need to do is just plug in 0.1. Just minus 0.1 times log P1 over P2. That's the result.
It's 0.2 in my
okay,
situation.
0.2. Yeah, it's fine. Yeah, 0.2. Yeah.
Okay, and I will get the result. But here, Doctor, shouldn't, what does 7 here? I have read it that he said 7 is the parenthesis in the uncertainty. Do you mean the range that we have found before from like in the tutorial to 15? Minus 15 to 15, the M range that we have found in the first step.
No, it's not. This one just give you the noise, right? How your digit is valuable, right?
So is 7 working for all of us?
Okay, this 7 is no, it do not relate to any of the number from your step 1 or step 2, right? This one just gives the fluctuations, right? We do we have the data, we take the average, etc. So how this number, this digits will be used for, please go, yeah, please go back to, go forward next slide, because this one you divide with it will
This slide.
standard deviation, right? We say it's related to the standard error, called a standard error. So you will understand that part a little bit. We do statistics. The main course is, all right, for this course is statistics. So we take the average, but there's another part, is the uncertainty, called a standard deviation error. It's an error. Analyze that. You may already have other training, like what? Like do experiments. I think you have go through the physics 101 or 102. You know how to do the analysis of the errors. The same here, right? Yeah, it's the same here. Yeah. So it's more or less. You still remember we do the size effect in our project 1, right? So so the size effect here is the n. If you see the accuracy is related to the size, to the system size, the number n. Okay. Here we only do one n. We use 216. So you just fix that, and you know what's the standard error we have.
And the X here represent what exactly?
X, you know, that represents the value you used, because each value you used, you take the average, right?
Which value? We have found a lot of value in this project.
Yeah, for example, you calculate quite a few, like P1, P2, and the delta G, right? The same. So here we consider the Gibbs free energy, right?
Okay.
So say G. The G, eventually you can think we take the G as an average. Right? Your each calculation you have many points. You take the average. Now you need to estimate. Although we have one number, to yourself is one number, but for the system, if you take, for example, n, different n, you will have different number. So how you judge your accuracy, your precision, that's related to your size, your system size, related to the n, right?
Okay.
Yeah, that's something you have never thought about, because you did not generate the model by yourself. Sometimes you may ask, why I take the model 216? Why not I take a 216 million atoms? So what's the number? What's the difference if I change the size, system size? How this just give you a general idea how trust of your data. So for your true data, this n should be what? Should be
216.
Now for the true number, it should be a very large number. Right?
Okay.
Because, yeah, for the real system is Avogadro. It's real large ones. Yeah. Yeah, this one just natural feeling how you trust your data, right? What's the error it could be?
Okay.
Yeah.
Well, that's it, I think.
Yeah. Yeah.
This is what I. Well, I'm not. I will
yeah.
not
Thanks
lie
for
to
the
you.
question. Yeah. Once
I
you
will
have
not lie to
question,
you
that
and
means you're sorry. Yeah. Yeah.
I will not lie to you and say I am fully understanding, but I will try because I don't know.
Why do I do that? Why I do that n small n? I have never touched small n, right? Because that's something at the beginning. We use the tutorial. We do not explain too much. because I hope, okay, first you follow these procedures, you know how to do it in a very basic ones. You have such skills. Eventually, you will need to understand what's the physical meaning behind these numbers. Yeah, that's important. Yeah, yeah. But at the first step and basic requirements, you need to know the simulations, go through these skills. Yeah. Hopefully,
Okay.
have finished these 3 projects. You already have get the sense how to what's the simulation, right? You already know what's the simulation, how to do the computer simulation, and have more difficulty is how you use these skills to solve the real problems, real issues. That's why hope you guys have a better, more practical projects. You can use such skills to solve the real problems.
Doctor?
Yes, please.
Is it required for from us to calculate this slide, or only to get we have to get the delta G?
You just need to get the G and do analyze or to discuss a little bit about your precision. As I said, the system effect. Yeah,
Okay.
system
Thank
size
you.
effect. Yeah, you just need one paragraph to discuss such things, right? And it's professional, etc. They should be fine.
Okay.
Doctor,
Yes, please.
when will the grades for project 2 be uploaded?
I think once you submit the project 3, I will give your feedback, your scores very quickly. Yeah. Yeah.
Thank you.
Yeah. All right. Other questions? All right. I think we can close this session. If you need other sessions, like please let me know. I will be happy to help. All right. Besides this course, if you have other issues for regarding the program, the other courses, I can also communicate with other professors to help you guys. All right.
Yeah, thank you, Doctor.
All right. Thank you very much. Have a good weekend. All right.